terms of this. But what you can also see is there where we added, for instance, H2S and copper, the levels started to increase again. It was almost the same as the control where no H2S was added to. Then apricot levels, flavors, and we're not sure what causes this flavors, maybe perhaps an ester or a terpene, or a combination of these things, also decreased where methanethiol was present, and drastically where H2S was present. And also the combination of methanethiol and H2S. Boiled egg obviously increased quite a lot where H2S was added, and this is obviously one of the descriptors linked to H2S is boiled egg. But again, where we added copper, you can see the levels, even after 24 hours, very quickly, the intensity of this descriptor changed or decreased very quickly, very rapidly. Cabbage, again, interesting, where methanethiol was added, the cabbage aroma was quite strong. So cooked veg, which is probably a combination of methanethiol and H2S, also increased, especially where methanethiol was added. And then the flinty sulfur, this is more a negative sulfur flavor, it's not a positive one, also increased quite a lot where H2S was added. So this was after 24 hours. Then after 6 weeks, again, the guava character quite similar, which was quite interesting for us. Passion fruit decreased a bit where methanethiol was added. Peach apricot also decreased again where methanethiol was present. Boiled egg, quite similar. So it seemed after 6 weeks, irrespective of the treatment, the H2S didn't really play a big role in this regard. Cooked veg, again, increased where methanethiol was present. And then even where methanethiol and copper was present, there was still quite significant, although it was not much higher, we could still find a bit more of this cooked veg character. And then the sulfur flinty, interesting again, where methanethiol was present, was also a bit higher. And then the last one is after 1 year, again, passion fruit at this stage was quite constant, and I think this is because the 3-MHA levels was quite constant. It's relatively the same at this time of the year, or at that time of the experiment rather. The methanethiol also decreased a bit the peach apricot flavor. And interesting, in some treatments where there was more copper, we started to find more banana candy flavor, which we think could be that the copper perhaps bound some of the thiols, which gave a bit more of the expression of certain esters, but we're just speculating on that. And then the cooked veg was also higher, again, where methanethiol was present. You can see even after 1 year. So after 1 year, the methanethiol, although the H2S seemed to, in this case, had very little effect on the sensory characteristics of this wine, the methanethiol definitely had still quite a large effect on these flavors in the wine. Then we also measured some of the chemical aromas in this wine, or compounds, and we found interesting, you can see there's no blue bar and no gray bars here, so there was no free H2S in these wines after 6 weeks and 1 year. But interesting, you can see there where we added some copper, and also there we didn't add some of we didn't add copper, but in some treatments the H2S levels, and this is bound H2S. So when it's bound to a metal, we release it by adding a bit of salt to the wine. So when it's bound, you can't actually perceive it. But remember, when this bound H2S becomes free later on, this could perhaps contribute to this reductive aroma increasing after extensive bottle maturation. So in this stage, although we saw increases in H2S, the panel couldn't detect it because it's probably still bound in this wine. Then the methanethiol also higher after 6 weeks in certain treatments where the panel could clearly distinguish it. I'm not going to talk too much about this, but you can see also where certain copper treatments was added, we still found quite significant levels of methanethiol, even free methanethiol in these wines. So to conclude for part 1, it's clear that H2S and methanethiol suppresses the positive descriptors linked to varietal thiols. In other words, those guava passion fruit flavors are suppressed by these compounds. But the good news is if you add copper, it rapidly reduces that negative aroma compounds. the copper seemed to, in this specific experiment, seemed to also bind a little bit of the positive aroma compounds, the 3MH or SMH3, but the extent to which it was bound is probably not enough to lead to a large decrease in the positive description of that passion fruit and so forth. The bound H2S can increase where copper was added, so this is something that the winemaker must take care of. Especially if you put your wine under a screw cap, which is more reductive. This will probably not really happen if you use a cork, but with a screw cap, the chance of this is happening is it's a bit bigger. Doesn't mean it will happen, but I'll speak about that a bit later again. And then copper also seems more effective of binding H2S and methane thiol. So if you have a bit of rotten egg, you're probably going to get rid of that easier than the rotten vegetable flavors. The wine matrix in this case was also quite effective in binding the H2S, and it actually bound the H2S more effectively than the methane thiol. So there's something in the wine that bound the H2S. It can be copper, or some other metals, or even some other oxidized phenolics. And it seems like the sensory effect of this methane thiol lasted much longer than the H2S. So methane thiol is really not something that you would like to have in your wine at a certain stage. Then part 2 of this work, we looked at swirling of a glass. How does it actually affect the reductive flavors in wine? So you all know sometimes if you open a bottle of wine, it smells perhaps a bit reductive. And people say give it air, let it breathe. We wanted to see what actually happens when you do this. So we asked ourselves the questions, are these compounds oxidized, these sulfur compounds, or do they simply just evaporate? What happens to them during the swirling of the glass? And we also wanted to look, at a reductive compound like H2S, but also one of the positive compounds like the varietal thiols. So basically here, we did this work in a model wine as well as in a real Chenin Blanc. I'm just going to show you the Chenin Blanc data now, but we got basically the same trends in the model wine as well as in the Chenin Blanc. So we had a control wine where we didn't add anything to. We just poured the wine and left it closed for 15 minutes. Then we had some wine where we added some H2S to. We left it covered in a glass after it was poured in a glass for 15 minutes. And that's, referred to as H2S. Then SC was basically a wine where we added, the same wine where we added H2S, and we stirred the glass and swirled the glass, and then we left it covered for 15 minutes. And then we had one where the same treatment where we swirled the glass, but we left the glass open for 15 minutes. And after 15 minutes, then we asked the panel to actually evaluate these wine. And you can see there's a student doing some of the swirling. He got quite strong after this PhD, swirled quite a lot. But we obviously try to keep it sort of uniform between the different treatments. So, interesting, the peach apricot flavors, you can see where there was H2S obviously decreased quite rapidly, but by swirling the glass, even if you left the glass open or closed, recuperated quite quickly. Same for pineapple. Pineapple decreased quite quickly, but the levels increased quite quickly where the glasses were swirled. Then boiled egg, which is obviously the H2S, was very high where the H2S was added. But again, just by swirling the glasses, the levels of, or the perception of this character decreased quite a lot. Then interesting, the sulfur reductive flavor decreased a bit where the glasses were swirled, even if they were closed or left open. But this flavor didn't decrease the same as the rotten egg. So there could be some fine nuances that the panel still perceived, in this regard. So we tested this at 2 different H2S levels, quite a high level and a low level, and we found basically the same results. Then interesting, we also measured the 3SH, in other words, that compound that gives you that passion fruit flavor in these 3 treatments to see, does the treatment actually affect these 3 flavors? This is with the H2S and the swirling glass closed and swirling glass open. You can see there was no difference. So the 3SH wasn't really influenced by just swirling the glass and leaving it for 15 minutes. But interesting, the H2S was obviously lowered quite a lot by the swirling. So then we asked ourselves, is this oxidation or is it just simple evaporation? So the student